Hello everyone, welcome to the course on entrepreneurial software development and management. My name is Professor Poonam Shinde and I'll be your instructor for this course. Yes, so here you can see ESDM subject is having 2 credit and this subject is for 100 marks where we have 60 marks NSEM exam, 20 marks INSEM exam and 20 marks is for your continuous internal evaluation where we have 15 marks activity and 5 marks is for your attendance. Okay, so course outcome. Let's begin with by discussing what you can expect to learn in this course. The primary goal is to provide you with a comprehensive understanding of the software development process and its practices. We will delve into the necessary knowledge of project planning, scheduling, and how to effectively allocate resources. You will also gain in-depth knowledge of the principles and practices of software project management. Furthermore, this course will equip you with the ability to use formal methods and explore the latest trends in the field of software engineering. Yes. So for this course, we will be referring a couple of key books. So first book is Software Engineering, a Practitioner's Approach by Roger Pressman. So second book is by Ian Somerville. So I'll also recommend a couple of reference books you that you might find useful, but my personal suggestion is refer this Roger Pressman Software Engineering the Practitioner Approach book. In this book the concepts are given in very easy language, so it is easy to understand, so you can refer this Pressman book. Okay, now let's look at the structure of the course. It is divided into 4 modules. Module 4 will introduce you software development methodologies. We will cover software engineering fundamentals, various process models like waterfall, incremental, iterative and agile methodologies with Scrum and XP, and it delves into software requirement specification, that is SRS, and we'll have some requirement analysis models also. So moving to the second module focuses on project planning. This includes project initiation, scope management and creating a work breakdown structure and project estimation techniques. Okay. Now module 3 is all about project management. We'll discuss quality concepts and management spectrum and crucial aspects like risk management in this model. Okay, finally module 4. In this module we'll cover the formal methods, recent trends and entrepreneurial product development. This model includes topics like testing strategies, emerging trends in project management and the fundamentals of developing a product from an entrepreneurial standpoint. Okay. Today we will begin with our first module, that is Introduction to Software Development Methodologies. Yes. So in this module we will be covering the introduction and need of software engineering. Then we'll cover characteristics of good software and the fundamental nature of software engineering itself. Okay. So what exactly a software is? It can be defined in few ways. First, it is a set of instructions that when executed provide the desired features, functions and the performance. It also includes the data structures that allows the program to effectively manipulate information, and importantly software also consists of documentation both in hard copy and virtual forms that describes how to operate and use the programs. Okay. what is software engineering? So let's break down the term software engineering into two parts, that is the software and another one is engineering. So we have defined software as a set of instructions and documents that deliver functionality to the user, and engineering on other hand, it is all about developing products and some inventions, and it is developing products using well defined scientific and mathematical principles and methods. So when we combine them, we'll get a software engineering term. Yes, so the IEEE provides a formal definition, that is the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. In similar terms, it is about establishing sound engineering principles to economically build reliable and efficient software that is reliable and work efficiently on real machine. Okay. Now, what are the different needs of software engineering? Why it is disciplined approach like software engineering is needed? Yes. So first one is handling a big projects. As a project grows in scale and complexity, corporations, companies need a systematic way to manage them without running into major issues. Next one is to measure a cost, proper planning and schedule and software engineering approach help in reducing unnecessary cost by focusing on essential requirements. Next one is to decrement the time. Following established technique can efficiently save development time. The next one is reliable software. It ensures that the software product is delivered on schedule and that any defects are addressed, leading to more reliable outcome. And last one is effectiveness. Effectiveness adhering to software standards leads to more effective and high quality product. Okay. Now, what is exactly a good software is? So the concept of good software is subjective and depends on who you ask. There are several attributes that determines if a piece of software is good or not. A customer and end user and the developer who build it will all have different perspective and will evaluate different attributes to divide on the software quality. Yes, so these are the some characteristics of software development. So we divide characteristics in several groups. Okay, so we have three groups: operational, transitional and maintenance group. So in operational we have multiple characteristics like budget, efficiency, usability, dependability, correctness and so on. In transitional we have interoperability, reusability, portability and adaptability. In maintenance the characteristics we have like a maintainability, modularity, scalability and flexibility. Okay. Now what are the different classes of software? So the software, we can classify the software into two main types. First one is generic software and another one is customized software. So basically generalized software is designed for a broad market with common and stable requirements that are well understood. Okay. The next one is customized software. So customized software is developed for specific customer requirements with a unique domain, environment and it is need that can be made by generic products. Okay. Now, what is the nature of software engineering? So here, in today's world, software plays a dual role. It acts as a product by delivering computing capabilities directly to the user, and it is also serves as a vehicle, enabling other technologies and systems to function effectively. Yes, for instance, an operating system is a product, but it is also the vehicle that allows other applications to run. Now, it's important to understand the fundamental difference between hardware and software. So first, software is developed or engineered, it is not manufactured, where the hardware is manufactured in classical sense. Yes, you cannot assemble it on the production line, where the hardware can assemble at a production line. Software does not wear out, where hardware can be wear out or trash out. Software may be outdated, but we or it is buggy, but it cannot be a wear out. And finally, while the industry is moving towards component based construction, most software today continues to be built in to meet specific needs. Yes. Then we have bathtub curve for wear out of hardware. So here, when we talk about a hardware wearing out, we can visualize it with this bathtub curve. Why this called as a bathtub curve? You can see here the curve looks like a bathtub. That's why this problem is called as a bathtub curve problem. So in the beginning, there is a high failure rate. You can see here high failure rate in burn-in phase. Then the failure rate is stable in useful life, but after some ages it increases. The failure rate increases again as components begin to wear out. Software, as we noted, does not follow this pattern. Now we have changing nature of software, where we are going to see different domains. So we have different domains like system software, real-time software, business software, and engineering scientific software. So first of all, we'll see what is exactly a system software is. So these are the programs that service other programs like compiler, operating system. Then we have real-time software. Okay, so real-time software monitors, analyzes, and controls real-world events like flight control system. Then we have business software. So these programs are designed to process a business information like inventory, then payroll. Okay, and this one is engineering and scientific software like CAD CAM software. So we use here number crunching algorithms for applications in scientific and system simulation. Okay, then next one is embedded software. So in embedded software, the software resides in RAM, and it is used to control the products and systems for the consumers and industrial markets. Specifically, it is typically very limited and specific functions. Okay, then we have AI software. So everyone knows and aware about the AI softwares. Everyone is using nowadays AI softwares like ChatGPT, then some pattern recognition applications. Then we have multiple games using AI. Yes, then next one is, and last one is internet software. So program that supports internet access and applications such as search engines, browsers, and some e-commerce platforms. It comes in internet software. Yes, so now these are the some examination questions. Okay, so first one is, what is software engineering? How does it differ from programming? This question may ask for 4 marks. Then next one is, explain the nature of software and describe its characteristics. This question may ask for 6 marks in your INSEM exam. Yes, then next we have the question, identify the various type of software applications and classify them. This question frequently asked in multiple exams. This question consists of 6 marks. Next we have some quiz questions. Yes, now first question is, which of the following is not typically considered a characteristic of good software? Yes, any cases? Options for this question is reliability, high cost, efficiency, and maintainability. Yes, so answer is high cost. Right, so high cost is not typically considered as a characteristic of good software. So next question is, how is software different from hardware in terms of life cycle. So options for this is, these are: software does not wear out like a hardware, software wear out faster than hardware, software and hardware have identical maintenance needs, and last option is, hardware can be reused more often. Yes, so what will the answer for this? Any guesses? Yes, so option number A, that is software does not wear out like hardware, right? So last question is, which type of software is usually built for specific client with unique requirement? Yes, so these are some options for this: internet software, embedded software, generic software and customized software. Yes, so right answer for software is usually built for specific client and unique requirement is customized software, right? Thank you everyone. The more you learn, the more you grow. So keep learning, guys. Thank you